Howdy everyone, I'm Biscuit, and I'm in a new place. Isn't that crazy? So you may have heard of electric fields, magnetic fields, and force fields, but what really are fields? Well, a field is one of those physical concepts that seems rather mysterious, but it's one we really need to nail down as they're so common in physics. So to get to fields, we're first going to talk about variables and functions. And so some of this is going to be a recap of things we may have learned in Algebra 1, but may have forgotten. So no matter where you are in your math and physics walk, I believe you can understand this. You got this. Okay, so the first thing we need to get is variables. So variables are just numbers that haven't been determined. They're still unknown and therefore could be any number unless they do get explicitly determined. They may not look like numbers because they're often represented as letters, but they are really just numbers, just ones you don't know. If you have more than one variable, there may be an infinite amount of numbers that solve an equation, which is where we need to start thinking about functions. Next, we have functions. In my opinion, the best way to think about functions is that they're just like machines. You give it some type of input and it spits out some corresponding output. Like if you put bread in a toaster and then it spits out toast. So for functions, one or more variables acts as your input, such as x we may be used to, and then a final variable, usually indicated by y, is your output. Okay, so then why should we care about functions? Well, they let us solve a problem once and for all, so that you can give an answer no matter what input you want. For instance, you could write down a function that tells you how much money you would have based on how much you invest, the number of years invested, and then the interest rate. So this function could take any starting value, duration, or interest rate, meaning you don't have to sit down and solve the problem every time someone new wants to know the answer for their specific situation. So this problem is now solved forever. And now you're allowed to go back outside, you can go play outside, you can drink some cocktails, I don't know, you can do whatever you want. Okay, so this finally leads us to fields. Again, we may have heard of fields in a sci-fi context like force fields, but the truth is a bit simpler and much more disappointing. So in physics, a field is just a function where the input is a coordinate, meaning your position, which could include time, and then the output of this function is usually a number or a vector. A simple example of a field is temperature. So imagine this, every point in your house has its own distinct temperature defined, up to the corner, to here, to every single point. So sure, it may be higher near your fireplace and then colder near your air conditioner, but it's still at every point it's defined. So you could write this down as a mathematical function, assuming if you knew the temperature at every point, or maybe just enough so that you can approximate all the points in between, then at that point, I could give you any coordinate in your room, and then you could tell me the temperature there. So another example of a field is with wind. So imagine a gust of wind rushing by, maybe rushing past you at some points, but elsewhere it could be swirling and spinning some leaves like little eddy currents. So the wind is not the same everywhere. It changes based on buildings, about things laying about, and even at just different times. So again, suppose I knew the wind velocity everywhere, and every time even, then if you gave me some coordinate, I could tell you the wind velocity at that point. So here the output of the field is a vector, unlike with temperature, which is just a number, since wind has both a strength and a distinct direction. So in this case, we would call this type of field a vector field. We may have heard of gravitational and electric fields before, but these are just different types of vector fields. Again, there's nothing magical here about what a gravitational field is. It's just if you give some coordinate, then you can get back the acceleration due to gravity there. So we have some good basic models of this with Newton's law of gravitation at the simplest, and then full-blown general relativity if you really want to get crazy. It's worth mentioning that fields exist regardless. We may model them as functions where the inputs are coordinates, but these sort of things we believe to exist apart from us. Temperature's still going to exist without us, gravity's still going to exist without us. So, at the end of the day, there's a little bit of separation from what I'm representing as a math and then the physical phenomenon. We believe that physics exists without us. We're just trying to sit around and understand what's going on, what we observe. Okay, so at the end of the day, fields are just physical quantities that we can represent as functions, where the input is a coordinate. So fields are incredibly common in physics and help us understand, and mostly help us model, the physical phenomena around us. Okay, so thanks so much for watching. Okay, bye. I just got the idea that I should do a video on the physics of toasters. I mean, you'd be surprised about the amount of stuff that they cram into this thing. Till next time.